Imagine a Fortune 500 company, right? They
Wow.
sink $50 million into a massive global marketing campaign. They are completely confident it's going to work.
Yeah, they're ready to launch.
Exactly.
Hmm.
Only to realize way later that their entire strategy was based on a single, unclean spreadsheet column.
Ouch.
Yeah.
That happens more often than people think.
I mean, it's terrifying. Welcome, everyone, to our latest exploration into the source material. Today, we are cracking open a recorded masterclass on data analytics.
Specifically looking at Excel, Power BI, and brand marketing analytics.
Right, because we want to see how high-level business intuition is actually built or completely destroyed by raw data. Our mission today is to demystify data science.
We really want to break down how raw, messy information becomes actual business insight. And the best part is, you don't need a PhD in mathematics to understand it.
Not at all. We're looking at this class not as some dry academic lecture, but, as a secret playbook for making smarter decisions.
Because the true magic, and I think the source material does a great job highlighting this, isn't in buying the most expensive software, it's the critical thinking a human being applies to that data.
And that system almost always starts with the tool we all know, Excel.
Oh, yes, the classic.
But we aren't talking about, tracking your monthly grocery budget here.
No, definitely not.
The source material frames Excel as this massive business intelligence tool. It's used for analytics, reporting, product management like tracking resources and timelines.
Yeah, and building fully automated dashboards using tools like Power Query and Power Pivot.
Right. But before you even get to building a fancy dashboard, you hit the analyst's absolute most important job, which is dealing with the historical data.
Dealing with dirty data, to be precise.
Yeah, the messy stuff.
Yeah.
Okay, let's unpack this. Because cleaning data, to me, it's like prepping ingredients in a kitchen.
I like that, Alex.
Like if you don't wash the dirt off the vegetables, the whole meal is ruined.
Exactly. And in the data world, that dirt is blank cells, weird formatting errors, or crazy outliers. If an analyst doesn't diligently clean and transform that raw data, the downstream reports are just compromised.
So they're fundamentally flawed from the start.
Right. The source specifically points out how this leads to severe bias. You could accidentally skew the numbers so much that you completely exclude an entire customer segment, or introduce serious gender bias into your reporting.
Wait, but how does a spreadsheet actually know if data is biased, or is that entirely on the human analyst?
The spreadsheet has absolutely no idea.
Wow.
Yeah, mitigating bias is entirely the human's responsibility. The software doesn't know the context of the real world. The analyst has to critically question the assumptions that are already built into the raw data.
Ensuring it actually represents the whole population.
Yeah.
That puts a massive amount of weight on the analyst, honestly.
It really does.
So let's say we do have a pristine, unbiased sample, like a carefully extracted subset from a huge, N,000-row database.
Yeah.
The masterclass moves into descriptive versus inferential statistics here. But here's where it gets really interesting. Have you ever wondered how TV ratings or political polls claim to know what millions of people think by only asking, a few thousand?
What's fascinating here is how the math bridges that gap. We have to start with the definitions.
Right. Population versus sample.
Exactly. The population is the entire group. That could be 300 students in a school, a whole nation of millions, or just a full data set with 10 columns and 10,000 rows.
Well, the sample is just a subset. So picking 2 columns and 1,000 rows.
Right. And statistics is just a calculated measure of that sample, like an average price or total sales.
So that brings us to descriptive statistics, which basically just answers what happened.
Yes. For example, calculating the total sales for a 2-week marketing campaign and comparing it to the whole quarter. You're just describing the data you have.
But then inferential statistics is taking those descriptive stats and using them to draw a conclusion about the entire population.
Exactly. The source uses a really clear example. Say you analyze a sample and calculate that the average age of men is higher than the average age of women.
Okay.
Inferential statistics allows you to use that sample to infer that this trend is true for the entire nation of Nigeria.
Oh, wow. So statistics isn't just crunching numbers. It's essentially the translation of past events into future certainties.
Precisely. You're quantifying your confidence in what you can't see based on what you can see.
But scaling up those projections means you are scaling up the risk, right? You
Yeah.
can't just run on unvalidated assumptions.
No, you absolutely cannot. You have to communicate from facts, not just what you think might be happening.
And that's where they bring in regression analysis.
Yes, regression is a statistical model. We use it to see the relationship between two variables.
Like the marketing example they give, plotting views against impressions on a scatter chart.
Right, and if those dots slope upward together, it mathematically proves a positive relationship. As views increase, impressions increase.
They give another really practical example too, like validating a marketing campaign.
Oh, the ClickVit ads example. Yeah, if someone guesses a campaign generated 50 million total views, you don't just take their word for it. You run the numbers to validate reality, which might actually just be 24 million views.
But wait, I have to challenge this a bit. If two things are growing at the same time, like say ice cream sales and sunburns, how does regression analysis stop us from assuming one causes the other?
This raises an important question. Regression validates the relationship and the direction they are moving. It does not prove causation.
Okay. That's a crucial distinction.
It really is. The math says these two things are happening together. It's up to the human to ask why and not just blindly assume the ice cream is causing the sunburns. You always have to question the root cause.
Which means you really need to get your hands dirty in the software.
Yeah.
Let's look at how this is physically executed on a screen, because navigating the Excel interface is kind of an art form.
It can be overwhelming if you don't know what you're looking at.
Yeah, like if you're flying a plane, the tabs, home, data, formula, those are your main control panels. And the ribbons, where you find text wrapping or conditional formatting, those are the specific switches.
That's a great way to visualize it. And then you have the grid itself, the horizontal and vertical lines, the column headers, the row records.
Right. Identifying individual cells like A1 or A2, and then typing out the basic formulas.
Starting with the equals sign, of course, using things like equals sum for total impressions, or equals average for average views.
And highlighting the range of cells instead of manually typing every single one out, which saves so much time.
Oh, absolutely. But where it gets really powerful is ED exploratory data analysis.
Right. So is EDA basically just playing around with the data until a story magically appears?
No, not at all. It's not random playing. It is a highly structured interrogation of the data.
Okay.
You're comparing variables, like analyzing the audience type men versus women by total views. And you use tools like pivot tables and pivot charts to spot these trends.
So pivot tables help you filter out the noise to find the actual signal.
Exactly. They let you dynamically shift your view so the real story comes into focus.
Which is incredible. But to wrap this all up, we have to talk about where all this data actually comes from before it even hits the spreadsheet.
Yes, the architecture of information. We have to look at ETL.
Extract, transform, and load.
Right. Extracting is pulling the data from a source. That could be scraping web pages or pulling from flat files.
Flat files meaning like CSVs, standard Excel workbooks, PDFs, or just text files.
Exactly. Then you transform it, cleaning and formatting it, usually using a tool like Power Query. And finally, you load it into a sheet or a data model for the actual analysis.
So what does this all mean? I mean, I'm just imagining a Fortune 500 company running its entire global operations off a single, terrifyingly large Google Sheet.
And that's exactly why they don't do that. If we connect this to the bigger picture, for large, scalable operations, companies use relational database management systems.
Like Microsoft SQL Server, MySQL, PostgreSQL, Oracle, IBM.
Right. A small startup might keep their customer data on a single Excel sheet at first, but big companies need databases for consistency, integrity, and security.
Yeah, because you can't safely store millions of customer records on a simple spreadsheet where some intern could just accidentally hit delete.
Exactly. Excel is a powerful lens to view the data, but the relational database is the secure vault where the truth is kept completely intact.
That makes total sense. So looking back at our journey today, we started with the vital importance of identifying and cleaning dirty data to avoid those terrible biases.
We covered the real difference between a sample and a population.
We looked at using regression to validate assumptions instead of just guessing. And finally, how everything is managed safely through ETL processes and secure databases.
It really highlights how much structure goes into what we think of as just business strategy.
It does. And I want to leave everyone listening with a final thought to mull over. We've spent this whole exploration talking about businesses rigorously cleaning their data to avoid bias and validating their assumptions before making a move. But think about the data you consume every single day in your personal life. The news you read, your social media feed, the unsolicited advice you get.
Oh, that's interesting.
Are you treating all that incoming information as a validated, comprehensive population? Or are you letting a very small, very messy, very biased sample dictate your entire worldview?
That is a phenomenal point.
Something to think about.
Yeah.
Well, thank you all so much for joining us on this exploration into the source material. We'll catch you next time.